In space, where the secrets and laws of physical science direct the importance of our reality, the James Webb Space Telescope, JWST, has arisen as an imaginative instrument prepared to rethink how we might interpret the universe. Not only are the revelations about far-off galaxies or the farthest reaches of the universe, but also about our own backyard. Pluto, long thought to be a dwarf planet, may have secrets that could change how we see the universe. Notwithstanding its downgrade in 2006 by the Global Galactic Association, IAU, which characterized it as a bantam planet following 76 years as the 10th planet, the public's reaction was quick and profound. However, for what reason does Pluto not meet the rules for full planet status? Furthermore, what's the significance here for how we might interpret the planetary group? Beyond Neptune, there is a vast region of space called the Kuiper Belt that is home to dwarf planets and icy bodies like Pluto. It used to be thought to be a lonely place, but now it's known to be very busy. The disclosure of articles like Pluto brings up issues about the idea of planets. On the off chance that Pluto is like these different bodies, would it be a good idea for it to be named a planet or only one of the more modest articles in this far-off locale? In 2015, NASA's New Skylines shuttle went by Pluto, giving the principal close-up perspectives on this bantam planet. The discoveries were amazing. Pluto is definitely not a dead, cold world, yet an energetic and dynamic spot with high icy masses, huge nitrogen fields, and a shockingly slim environment. One of New Skyline's most thrilling disclosures is a sea underneath Pluto's cold outside layer, warmed by radioactive rot in its center. This sea might be livable, making Pluto a superb possibility for the quest for extraterrestrial life. Enter the James Webb Space Telescope. JWST has the potential to unravel the mysteries of Pluto and its hidden ocean thanks to its one-of-a-kind capacity to peer deeply into space and time. JWST can learn more about the hidden ocean's existence and habitability by studying its atmosphere and surface. Pluto's environment, generally nitrogen with hints of methane and carbon monoxide, is a dainty layer not handily made sense of. The sun's structure and composition will be examined by JWST as it passes through Pluto's atmosphere, revealing its preservation processes. There are a variety of landscapes on Pluto's surface, from flat plains to rugged mountains and high ice sheets. The heart-formed locale known as Sputnik Planitia has entranced researchers because of its consistent newness, brought about by the buildup and arrival of nitrogen dioxide. JWST's capacity to recognize unpretentious changes in temperature and creation could reveal what lies underneath this frozen spread. Pluto's biggest moon, Charon, is an unmistakable planet with its own qualities. It is fascinating to observe Pluto and Charon interact, particularly their material exchange. Styx, Nix, Cerberus, and Hydra, Pluto's 4 small moons, also dance in a complicated system. The dynamics of this far-off system and the origin and evolution of these moons could be better understood with the help of JWST observations. While New Skylines gave mankind its most memorable close-up see Pluto, much still needs to be learned. Future missions, potentially including landers or submarines, could investigate Pluto's subsurface sea and give conclusive responses to questions raised by JWST and different telescopes. These missions could find out if Pluto has life and if this faraway planet holds the key to understanding how life started in the solar system. Disclosures made by JWST and different telescopes about Pluto have expansive ramifications for how we might interpret the nearby planet group and the universe. If Pluto, when remembered to be a cold and dead world, can hold on to a secret sea and potentially even life, what's the significance here for other frigid bodies in the Kuiper Belt and then some? Could there be other worlds farther out in the solar system that are as alive and vibrant as Pluto? As JWST returns information, researchers are re-examining what they had some awareness of the nearby planet group. Pluto's change as a bantam planet is only the start. The disclosures about this far-off world are inciting a reconsideration of the rules for being a planet and the cycles controlling the development of planetary frameworks. Clyde Tombaugh, the space expert who found Pluto during the 1930s, would never have envisioned the effect his revelation would have on how we might interpret the nearby planet group. As JWST investigates Pluto, Tombaugh's heritage keeps on developing. His disclosure, when thought about a minor detail, is presently at the focal point of significant inquiries concerning the idea of planets and the potential forever. Pluto's excursion from the 10th planet to a bantam planet and presently as a possible support for life has caught the creative mind of individuals around the world. This little world, situated at the edge of our nearby planet group, represents the ceaseless development of science and the secrets that look for us in the universe. Pluto's story is not just a myth. It's about interest, investigation, and the human need to grasp our spot in the universe. Pluto's grouping as a bantam planet has started expanded interest in little items in the external nearby planet group. The investigation of bantam planets is a pivotal area of exploration. Researchers plan to comprehend how these bodies look, develop, and connect with their current circumstance. JWST plays had a critical impact in this exploration, giving new bits of knowledge into the physical and substance properties of bantam planets and their moons. Whether or not life on Pluto proposes that life may be conceivable somewhere else in the Kuiper Belt or past is charming. New avenues for the search for life will open up as a result of JWST's ability to detect chemical signatures of life in the atmospheres of distant worlds. From Earth, researchers are additionally exploring life on other bantam planets, including the moons of gas Goliaths like Europa and Enceladus. Revelations about Pluto and other far-off planets are impacting the universe of science. JWST is at the front of this upset, giving researchers the apparatuses they need to investigate the furthest reaches of Earth and then some. As how we might interpret planets and their capacity to have life keeps on advancing, the past becomes more clear. Our continuous investigation of the planetary group and the universe's past continually helps us to remember the amount we don't have the foggiest idea. Trend-setting innovation and the force of JWST have permitted us to see a greater amount of the universe than any time in recent memory, uncovering it to be more complicated, dynamic, and baffling than we at any point thought. New research and discoveries have been sparked as a result of the findings, which have challenged our understanding of the world. As we keep on investigating the universe with JWST, we are reminded that the universe is brimming with miracles and that there is still a lot to learn. The revelations of this telescope have given new chances to grasp the universe and have motivated another age of stargazers and researchers to investigate its secrets. Understanding how galaxies change over time is one of the most important lessons learned from JWST's observations. The universe's building blocks, galaxies, have been the focus of intense research for a long time. The disclosure of 6 stars that shaped 500 million years after the huge explosion is very surprising. This disclosure gives significant data about the components and cycles that prompted the development of cosmic systems in the early universe. Using these observations, models of galaxy formation and evolution have been improved. The information show that early systems framed quicker, amassed all the more quickly, and were surprisingly intricate. Our comprehension of the timeline of the evolution of galaxies is challenged by this finding, which also raises questions regarding the mechanisms that cause rapid growth. The disclosure of these early cosmic systems is likewise significant for how we might interpret dim matter and dim energy. Dull matter, which doesn't produce or mirror light, makes up around 27% of the universe. It assumes an urgent part in the development of worlds by making the encompassing vast system whereupon universes can shape and develop. The fast arrangement of these early systems proposes that dim matter is more amassed in certain areas of the early universe where worlds framed all the more rapidly. Then again, dim energy is accepted to make up 68% of the universe and is liable for its fast extension.